All right, Algebra 2 here. We're going over the second half of this study guide, this practice test. And yeah, so I just taught you guys in class, and we're talking about how like some of these problems right here, that these are basically the same type of thing. These three problems here, what makes it 0, and this one was like a little bit different. I was tossing these on here to really emphasize that sometimes when the problem just has an x in it like this, there's no y, then our answer is just these two answers. So we would say x is equal to 9 and negative 1 1/2 for this one. We could have them written as two separate answers or combine them like that. That's fine. Same thing over here. We get two answers. Up above, these are written as ordered pairs because this is an equation, not an equation that's a function. So we kind of have like y equals this stuff. And so we're asking ourselves, in order to get the y value equal to 0, what values would we have to put into this to make it equal 0? Here it just says it equals 0, not y is equal to 0, but here, here we're imagining what if we made this y value equal to 0. And that's why we get pairs of answers here, an ordered pair, and I set these up, and on the test I'll set them up the same way. This is not written as an order. So my point is, if you wrote 9, 0, that would be correct if it was asking for a function and what would make it, but this is not the correct answer when it's not written in function notation. All right, so that's a little clarity on that. A little clarity on these problems down here as well is that when we look at this, we are solving these in a way that helps us with really writing them in vertex form, equations. We're setting them like equal to y for these. So, all right, we solved this one in the last video. In this video, let's focus on this one. Really, writing this as a perfect square is a different question than writing something in vertex form. And if I were to take this and write it as an equation, I would write it as y equals x squared plus 4x. And if I'm going to write in vertex form, I know that I'm going to have a mystery number here, but altogether I already have 9. So 4x plus 9, that mystery number, that doesn't match up. I'm going to zoom in now so that we can focus on the details. That doesn't match up. I want this to be x squared plus 4x plus 4, but I had 9. So because I had 9 in the original equation, if this was an equation, then 4 of the units can go here, and I end up with extra. I end up with extra units. And how many extra units? 5 extra units. So to write this in vertex form is written in the form of y equals ax minus h squared plus k, where h and k are the values, h comma k are the values of the vertex, okay? So since those are the values of the vertex, we want this to be in this form where this is a perfect square. Don't worry about the a value. There's no number in front of this x squared, so there's not going to be a value there except for 1. It's going to be 1 and it disappears. So what does this look like? Y equals, I take this part and convert it into the perfect square that it was, an x plus 2 times an x plus 2. X plus 2 times itself, which I can write as squared. Now look at that. That looks like this form, except I need a minus sign here. And if I had a minus sign there, since this is plus, I would have minus a -2. So -2 is technically the h value. So if I were to find the vertex of this, the vertex would be a -2, comma, what's the other value that we get here? So all of this was turned into that, and we had 5 extra units left over. That's our k value, 5. That's our k value. So 5 would be our -2, comma 5 would be our vertex. It means if we graph this, we would go back 2 units, up 5 units, and that would be the turning point. That would be where the vertex would be on our graph. Okay, let's look at the last one. how do we take this and rewrite it into vertex form? Well, we already did it as a perfect square. All right, we need that number down here to be an 81. So if I were to take the original, what was the original? X squared plus 18x plus 4, and write it y equals x squared plus 18x plus 4. That's the original written as an equation. Now I want to transform that. I want to focus on this, and we already did the work for that. The whole point of having this graphic organizer was to help you kind of organize the effort so that you could say, oh, x plus 9 times x plus 9, that would make a perfect square if we had an 81. All right, so we'll get y equals, we need x squared 18. We need the next number to be an 81. That's what this was saying. But here's the thing, the equation has 4. Well, all 4 units can go here to make that 81, but I'm missing 77 units. If I had 77, so I take 77 units and put it here, and I take the 4 and I put it here, and what I'm doing is I'm inventing numbers out of nowhere. So if I put positive 77 here, then I have to also add negative 77, so that I'm basically adding 77 and adding a negative 77. I'm adding 0 to this expression. That's what we're doing when I'm doing that. So 4 goes here. I still need 77 more. That means I'm 77 shy. And so I'm bringing positive 77 actually goes there, and it's disguised in there, and this negative 77 is what's missing. What we're short by. We're short that many. Okay, so now how do we rewrite this? Remember that this now is a perfect square. X squared, 18x, and 81 is a perfect square. I can rewrite it as x plus 9 times x plus 9, x plus 9 times itself squared, and that minus 77 will be right down here, minus 77. Now this is what it's written like in vertex form. If I said, what is the vertex? You would say, well, the vertex would be equal to the coordinate, the h and the k value. So basically it's the opposite of what you see here, a negative 9, and it is the number that you do see here, not the opposite. So a negative 77, you keep it just as it is. Opposite of this, keep that. So yeah, these are our answers in vertex form, and vertex form, and vertex form. Let's move on to the back. Okay, now, all right, I've already got my answer key made for the back. I am gonna redo it from scratch though. Okay, so I have this nice little colored version that I'll take a picture of and submit for the picture online. This one, let's do it from scratch. Now, what's the purpose of this problem? This problem is one where we've done 3 different forms of quadratic equations, something that has an x squared, x times x would make an x squared. We have the standard form equation. That standard form can be factored, and it can also be turned into vertex form. So I'm not making you do any of the math of factoring it anymore like you did earlier in the test, and I'm not making you complete the square. What if I gave you that these 3 were the same function? What information do you get from each of these? Well, we just saw that we get the h and the k value. We get our h and our k value from this vertex form. And so so we want the opposite of this, which would be positive 4, and we want to take that number as it is, a negative 9. So at 4, negative 9, we get the vertex of the parabola. That's some information that we get. This right here, what information can we get from this? Well, this last number here is the y-intercept. So the y value would be 7 when the x value is 0, 0, 7. This is our y-intercept. All right, and what information do we get from this? When it's in factored form, by the way, remember that this, and this, these 3 equations are the same equation, just transformed into different forms. So this is saying that you know, if we were to graph this, and we were to go 1, 2, 3, 4, and then down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, that would be where the vertex would be. And at 0, 7, 0, 1, 2, 3, 4, 5, 6, 7, that's where the y-intercept is. This is saying that we get the x-intercepts, the zeros or the roots, all right, of this when we solve this. So a positive 7, 0 would make this 0, or a negative 4, 0. So what are those? Those are our x-intercepts. So at 7, 1, 2, 3, 4, 5, 6, 7, that is a point, and at negative 4, negative 1, 2, 3, 4, that is an intercept. Oh, what a way is this? Maybe these aren't all three the same equation. Because I'm looking at this, I'm like, how the heck do we make a parabola out of this? And it's not quite working, so maybe, maybe these aren't the same. Okay, anyway, when it's in factored form, we get the x-intercepts. When it's in standard form, we get the y-intercept. When it's in vertex form, we get the vertex. I gave you a little vocab word bank here that everybody in the class can look at, and I want you to see that there's extra words in here. All right, but the word x-intercept, y-intercept, and vertex are the ones that we ended up using for this. Okay, last problem. So this, we're going to split the paper into 3 parts. We have choices as to how do we want to solve this. Now with all of these, I can use my quadratic formula. Boom, I could solve these because this is set equal to 0, equal to 0, equal to 0. I can solve all of these by using this formula. That's what I'll do for these two. This one, I could use the quadratic formula, seeing my a value is 1 and my b value is -2 and the c value is -8. However, here's the thing. I know that I could take this and write this in factored form. All right, I could get a little box and do the box method and write this as x minus 8x plus 6. If I multiply those, I get -48, and if I add those, I get -2. This is faster. This is faster to do this in factored form. Now, what makes these 0? Well, x would have to be equal to +8 or a -6. These are our 2 solutions. Okay, that's the fastest way. Again, I could have used the quadratic formula, just take longer. This one right here, I already did the answer for this one, and the answer is a decimal. You know, for the sake of just kind of like looking at the work, here it is. All right, this is ugly, the ugly numbers. It's not going to factor nice, so we're going to use the quadratic formula. So I'm going to take the opposite. Here we go. I want the opposite of the b value. So that 9 is going to be a -9. There it goes. Then under the radical, I have plus or minus the square root of the b value squared, which would be 9 squared. 9 times 9, 81. Okay. Then I'm going to have -4 times a, which is 4. -4 times 4 times the c value, -7. -4 times 4 times -7. Now we have a negative times a negative. That's going to result in a positive. When we do that math, I'm going to zoom in here. When we do -4 times 4 times -7, we get positive 112. Add that to the 81, and we get 193. Now that doesn't have a nice square root, but it's 13.9. So we can roughly say it's 13.9, and we'll use that going forward. The bottom of this, remember, the bottom is twice the a value. The a value was 4, so the bottom number, our denominator is 8. 8 dividing by 8. So because we took the square root of something, we're going to have either adding 13.9 or subtracting 13.9. And this is just calculator work. All right, so I'm pretty sure all the ones I gave you on the test work out to nice round numbers, nothing ugly like these decimals, but it's still worth doing. All right, this one right here, same thing. I have the opposite of the b value, so the b value is -5, so I put a +5, plus or minus the square root of the b value squared, -5 times -5, which is +25. And then I have -4 times the a times the c, so -4 times the 3 times the -2. Now I have a negative times a negative, that's going to be positive 8 times 3, which is 24. Remember, the bottom here is twice the a value, so I take that 3, I double it, and put a 6 there. And here's my expression. Now 25 and 24 makes 49. Great, the square root of 49 is equal to 7. And so we have 5 plus or minus 7 divided by 6. So I split it up into 2 problems. 5 plus 7 divided by 6. 5 plus 7 is 12, divided by 6. 12 divided by 6 is 2. And 5 minus 7. Remember, plus or minus means I also do 5 minus 7, which is -2, divided by 6, so -1/3. Okay, that goes over the entire study guide, the practice test for this. Now remember, there'll be one more problem where I give you the quadratic formula all solved out. It's a student's work, but the student made a mistake. And so you have to carefully look at what they did with the numbers and, you know, did they make a mistake using the quadratic formula? Okay, that's 2 15-minute videos going over the front side and the, you know, and the back side of, or this whole packet of this test. Hope that made sense. Take care, folks. Bye.